And now we will actually invite one of our long-term friends, contributors. We'll be talking about multi-tenancy Zabbix metrics processing together with Zabbix streaming. Let's welcome CEO and owner at Inqbeo, Germany, Christian Anton. Welcome.
Wow, feels great to be here on stage at the Zabbix Summit once again. Thank you for having me here. Wow, I still feel kind of nervous every time, even though it's not the first time being speaking here. Okay, let's probably first talk a little bit about the long and clunky, or kind of clunky title of my presentation that I'm going to try to give you today. And we are actually today not talking about how to do crazy things with Zabbix. We do a lot of crazy things with Zabbix, you all do, but this time it is an example in a real-world scenario that we built for a customer of us, and it's less like putting crazy things into Zabbix, it's more put Zabbix into other crazy things, right? So sometimes even such a great monitoring tool and such a platform as Zabbix is needs to just play the role of being a little piece of something. And in this case, we have an integration use case that I'm going to show you how we did it. I'm not going to say this is the only way to do it, but as I got inspired by summit speeches to make this happen this way we did, I hope that the presentation I'm going to give you is hopefully inspiring some of you if you have a similar or even the same use case someday. So before we continue with what we actually did, please give me these 2 minutes to talk about who I am and who we are. Who is this Inqbeo? Yeah, as the name a little bit tries to say, we are all into building cool and new stuff today that may be normal tomorrow. So we are in a very strong in the areas of monitoring, of course monitoring, but also in the entire area of IT automation, container technologies, DevOps, GitOps, you name it, all those nice lovely buzzwords. We do this kind of things. Okay, and my connection to Zabbix is, of course, already quite long. I am, with different companies, being a Zabbix partner since, I believe, almost 10 years, maybe 9. I have a 7 here, so yeah, already getting an old Zabbix dinosaur here. Okay, and consulting company, and we offer all kinds of things that our customers want and need, and try to create some benefit with modern technologies. Talking about modern technologies, we had a customer, an organization that, well, works in the wider healthcare area. As usual, those customers or those companies, they consume a lot of IT services from a specialized IT provider, a big IT provider that offers them all kinds of, Windows networks, firewall, servers, virtual machines, application platforms, shared services, and so on and so forth. But they are not only consuming services from them, they are also consuming services from other providers. They are running some stuff themselves. Every company has printers and some network connection and stuff like that. So they came up with a need to get a little more control over all that. And their idea was not like to get every metric from every server and everything. That the approach was more to get like a higher level picture on all these streams of services that they consume. And One thing or two things to be seen on the lower right corner were already like decided from them. We have to also take in mind that the initiation of this project was back in 2021, 22. So for the visualization layer, the clear option here for them was to choose Grafana, and that was already one of the first like little challenges. And the second decision that they came to us with already taken was that the entire stack had to run in Red Hat OpenShift, which actually was good for us because that's one of our preferred platforms. What they wanted really is to get metrics from several sources, but the main source would be the Zabbix monitoring system that is run at that service provider. And now you may imagine you have a service provider offering all kinds of services to different organizations. You have shared services where you offer like, I don't know, an email service to 3 companies, and you host some stuff that is specific for one company, and so on. So there is no clear one-to-one connection here, and this multi-tenancy has been the biggest challenge in designing an infrastructure. So what we came up first with, and sorry for the really ugly picture here, I try to do better pictures later, was more or less this, right? We have a big Zabbix, a running Zabbix system on the left side. It's a rather big Zabbix installation, not huge, but also not small. We have around 7,500 hosts in there, 6K values per second. If I remind correctly, you know, these numbers tend to go up and down a little bit. And we came up with the idea, okay, so we need to build something like to get all these metrics data from this Zabbix and somehow do a kind of magic to filter this and to find out, okay, which data is really the data that belongs to that customer, and even more important, which of this data we are actually allowed to give to that customer. Because if you are a service provider, you kind of live from the fact that your customer receives the service or can consume your service, but he doesn't know how good or how bad it is performing internally. So you are probably a bit of careful with what metrics data you want to give out of your monitoring. And that was basically the biggest challenge we had to address, really, to make sure to filter and to only give out the data that this customer may receive, right? Okay, I have separated the infrastructures a little bit, so you can see we were planning like a data hub kind of platform on the left side that is owned inside the service provider's infrastructure, and on the right side we have the customer-owned infrastructure part, which, well, at the beginning it was clear, yeah, we need the Grafana here, and we somehow need to make the data accessible to that Grafana. Okay, so we started with this, and then we started thinking, we need to take the first decisions, and we clearly came up with, okay, we need some kind of a stream processing. We need to be able to move a lot of data from A to B in real time. So decision was taken pretty quickly to use Kafka here. Kafka as a stream processing ecosystem, really being built for high performance, for a lot of messages per second. That seemed to be a good option to start with. And beside of Kafka being very powerful and really big, it has a cool and extensive ecosystem of a lot of like programs speaking that Kafka language, so you can input data, output data, and so on. And beside of that, in the Red Hat OpenShift platform, we have the possibility to use the strimc operator, which in Red Hat OpenShift comes with a product name, something with streams, but it's actually this. And it makes it very, very easy to declaratively manage and build and maintain Kafka clusters. So the burden of building up an entire Kafka infrastructure was not that big anymore. It was just a piece of YAML. And yes, I have been asked yesterday whether I will have some YAML in my presentation. I had to double check, but yes, I have some YAML in presentation. Okay, so Kafka was taken the decision very quickly. Additional to that, we looked at Grafana at the visualization layer, and we found out, well, if we are free to choose which data format we will put the data in, the metrics data in, we decided to go for the Prometheus, the data format, because at least back in that time, and even nowadays, I would say, if you have to use Grafana for dashboarding and visualization, the Prometheus metrics are probably the easiest to consume because Grafana is kind of made for that kind of data. So we decided, okay, target format will be Prometheus data, and now we need to decide where to store it. That was also an easy decision because we are using the Thanos long-term storage for metrics data in other projects, so we decided, that piece fits here, let's use that. So our infrastructure idea became more complete, but still we had a couple of moving parts which we had no idea on, and I'm going to go through this with you. So first of all, we needed to figure out, okay, how do we now get data into that stack, right? We know that we have this Kafka. Kafka is able to move around a lot of data. This is nice. Somehow this data will end up in something and somebody will look at it. Nice, but how to get the data in? And we needed to have a look at two things here. One is really the metrics data. You may imagine in metrics data, it's usually like a timestamp, an identifier, and a value that is measured, like 10%. If we look at what Zabbix is capable of actively streaming metrics data, you will nowadays see that it has a native, almost native support for Kafka. That was not there back then, so we couldn't use that. And I was talking about inspiration from Zabbix, from Summit talks, and there was a Summit talk, I think it was around the 2021s, 22s, I know there was this COVID thing, I don't exactly remember, but there was a Summit talk with a loadable module that you could compile into Zabbix server that was able to stream the metrics data through HTTP. We tried that. It didn't work out as good as we were expecting because just, the latencies and the HTTP protocol not being so well suitable for this amount of data. That's what we found out. What we came up with that performed much better was the real-time export of Zabbix server in JSON files, which most of you may probably know that it exists, and using a little open source tool from a competitor here, from Datadog. Datadog has this little vector agent, which is basically comparable to maybe FileBeat or one of those. So it's really like a Swiss Army knife for all kinds of observability data. You can define like inputs and outputs, and it does things. So one input is JSON files, or ND-JSON to be completely correct here, and output was Kafka. So we already were able to send our metrics data stream into our data processing platform, which is nice. But then we found out, well, we need a little more of meta information rather than just host name, tags, and stuff like that. We wanted to have also the units of each of the items, the item type, the item key, so we could process this information better. And there we thought, well, there's Zabbix API. So we didn't find anything ready-made for that. Zabbix API to Kafka transformer. So we built our own, a little Python program that basically goes towards the Zabbix API and gets all items, all host groups, all templates, and every configuration information from Zabbix and puts it together in one message per item. So in this case, it's like a 700,000-800,000 messages, and we send this into another channel, another topic of Kafka, just the meta information. And from this, we now have the data in our stack, and we can have a look at the data. Okay, it's rather small maybe, but what you can see here is one message just containing one value of a metric, just at one point in time. So you have a timestamp, you have a value, and the most important, the item ID, which we later can map to the metadata. Okay, and we have this other message which comes from the item configuration that might look familiar to some of you. You have a standard Zabbix item. I just chose one example here. It has a unit, it has a description, and yeah, it's a Zabbix item. And here comes the YAML, actually. So our little Python program, it has a rule engine inside, a very little rule engine. So we can write in YAML a rule set to say, okay, these items from these host names, or if the template of that host matches a certain string, a regex, and additionally the item has this and that tag, and the name is not whatever, we can build these kind of filters and tag the item messages with a customer field. And based on that customer field, we can then redistribute the data to the different consumers. And this is such a message containing the meta information. And yeah, you see I have grayed out the customer field, so you can put your company name in there. And yeah, that's how it is. So now we have the challenge of having two streams of information in our Kafka. Shown here as the orange fields, like you have the topics on the very left side, the values input and the meta information input. And now here comes the good magic of Kafka. Kafka is able to build such applications inside Kafka that is called Kafka streams, where you can mangle and filter and reorder and not reorder, but merge data. And as we are not the best Java developers, and actually nobody really wants to be a Java developer, we were happy to find KSQLDB, which is an open source development of Confluent, if I'm reminding correctly. And they offer like an SQL interface to build those streaming applications. And then we can operate on our streaming data just as they were in a database. And you see this in the picture below. We have a stream of information containing our values, the metrics that come in, like the measurements, like those 6,000 per second. And you have this other stream where you have an indexed table by item ID. And every item sends such a message, and you have, like, for every item, the last message in that table. So if you want to update some metadata of an item, you just send this message again, and it will update the table. And with this information in the Kafka ecosystem, we can do a join, merge this data together on the item ID. Later, we can filter out with a simple select and distribute the data towards other Kafka topics, right? And this Kafka topic on the right side will actually be the interface towards the customer part of the platform. And so you have a classical username, password, or certificate-based authentication towards the Kafka, which contains only permission to read from this topic, and you are kind of fine and clear here with the data distribution. Yeah, the KSQL queries look a little bit like this. No, not a little bit. They look exactly like this. So at the top you see creating the stream, then you create the table, then you create a stream that merges or that give me a second, that joins from those, and then you choose only those having a set customer on some value, and you push this out into another Kafka topic. And yes, it's basically standard SQL with a little bit of extra annotations like the topic names, etc. So very easy, actually. And what comes out of this is basically such a little message combined of those two things, right? So we now have our measurement value here. We have the timestamp here, the clock. We have host groups, host templates, units, and all those things that come from the metadata of Zabbix in the Kafka message going towards the customer. And with this, we can now think about how to get this data out of the platform and to make it visible for the customer. Well, that was also something we didn't find any tool that was ready-made for this, and therefore we came up with the idea, well, then we need to build our own. So again, a little microservice written in Python here. It probably would have been even better to write this like performance-wise in Go or whatever, but we decided for Python here because it just worked well. And this one actually listens or consumes the metrics on that Kafka topic and converts them into the Prometheus metrics. It pushes the Prometheus metrics by a default Prometheus-owned protocol, which is the Prometheus remote write protocol based on HTTP, a serial binary serialization and compression, which is very high bandwidth capable. Okay, so we push the data into the Thanos. Thanos stores the metrics data in a S3 storage bucket. Thanos comes with integrated capabilities to do like downsampling data. It comes with the integrated functionality which we know from Zabbix as housekeeping, like deleting the old stuff, and behaves pretty nicely here. Yeah, and then we have our Grafana consuming this data from Thanos, and that's basically it, right? So a metric that we can see in Zabbix on the top left there. You can see on the right it appears in the Thanos web interface. You also see on the down part of the slide, you can see this metric in the label view, and you can see all this. Well, you probably can't see it because it's too small, sorry for that. But what you would see, if you could, would be that all those meta information coming from the Kafka messages are being converted into labels of that metric, making it very easy to consume these labels or these matrix then in dashboards to build tables, to build dynamic whatever calculations, etc. And that's almost it from my side. Of course, I could like talk another 2 or 3 hours about all those other fancy stuff that we have built in here. Just to mention some, we have added on the client side a Redis exporter, which is something where we can store meta information like location data, CMDB-based data, asset management data in a Redis database, and we have a generic interface that generates metrics based, informational metrics based on this Redis information. So we can feed data into our Redis with different kind of data feeders and consume this data to merge on query inside our dashboards. But that goes a little bit beyond. I just thought it would be interesting to just mention that we did a little more than just that. Yeah, and we have a transport bridge built that allows us to build a subscriber model for a chat platform that the customer used, also part of the customer side, of the client side. And so we are able to consume data from different sources, put them together in the metrics platform, and yeah, visualize them and work with them on the client side. And conclusion on that, we hopefully, at least we are running this platform for and with the customer now for some years. So I can, from my side, say we hopefully did it successfully. We built really an enterprise-ready data platform with Zabbix as one and the major data deliverer here. It really operates at high performance. We did not see any problems in regards to too many messages or such. Yes, it consumes memory like crazy, but that this is just money, right? So it is easy. And yeah, we have this full multi-tenancy, and that was the major challenge we had to address, that we cannot say okay, all this host group is belonging to that customer. That's not the reality. It's like out of this host, there's 3 items that the customer may never see, and there's this one item that we agreed upon he may see. That we haven't had another good option to realize that, and this works pretty well. And the good thing is that the entire structure as it is rather reusable, so we are already onboarding additional data streams on the output side, because now we have the data there and we can redistribute, we can filter more things, we can aggregate more data into it, process the data, and give some other of the customers some other of the metrics data, and that made it pretty extendable and quite flexible. And that was it from my side. I unfortunately have no idea how I'm doing time-wise, because my clock here just stopped. So I hope I am not super fast. But thank you, and if there are questions, I hope I can answer them.
There is one. There is one question from the audience. How can you translate plain Zabbix item keys into Prometheus human-friendly labels and values? Are ad hoc rules needed for each case?
That's a very good question, actually. When I was talking about the part getting data out of the platform, I mentioned that we have built a custom Python-based microservice here. And what that microservice does is it uses the item key of that item, throws away the part of the arguments, turns these arguments into labels, and uses the item key as the label name. Of course, transforming dots into underscores and stuff like that. So as an item key is usually something identifying one. Let's use a CPU usage, or system.cpu.util, which you can have a system CPU util like %used or whatever. You can do exactly this in the Prometheus world. So your metric would be system_CPU_util with the appropriate labels on them.
Yeah, got it. I think that answers it. Thank you.
Thanks to you guys.